And welcome everybody. I am Durgesh. I am the founder of WeLEAP Aerospace, and I'm also the president of MIT Researchers and Postdoc Association of Aeronautics and Astronautics, abbreviated as RPAQ at MIT. And today we are having this outreach panel session where we have invited two MIT students and one MIT postdoc to share about their journey and their career path, how they navigated different milestones in their career, and also to talk about their research a little bit. So the session is meant to be highly it's an overview, but also it gives you some depth on how to navigate through the technical and soft skills required to have a good research career in aerospace. And last but not the least, we have Miss Palak Patel. She is at MIT Nest Lab, and she's also an STGRO fellow, and she's working on the field of producing oxygen and lunar steel in space.
Okay. All right. Hi, everyone. My name is Palak Patel, and I am a fourth-year PhD student at MIT. And I'm just going to talk a little bit about my journey and what brought me here. Yeah, so let's get started. All right, so my background, this is a lovely picture of my family, and I wouldn't be anything without them, so I think that's very important. I was born in Detroit, Michigan, so that's where I started out. And when I was 9 years old, my family moved to Houston, and we stayed there for about 4 years. And just at the beginning of my high school, my parents decided they wanted to move to India. So we moved to India. And after doing high school and undergrad and a year of work in India, I came to Cambridge, Massachusetts for grad school at MIT. All right, so career path. So I'm just going to begin at my undergrad days. I went to a university in India called Pandit Dindayal Energy University, and I did my bachelor's in mechanical engineering. I did a lot of research while I was here in my undergrad, and this research involved a couple different things that I've listed here. So designing a gearbox for a single geared cycle, like a more cost-effective method so that people in India, if they've got a single geared cycle, they could just attach this gearbox and be able to cycle a little better. I also worked on research with machine learning to predict tool wear rate of milling machines, and this data was collected by NASA. And my main focus, I'd say, for my research during undergrad was the electron beam welding of dissimilar metals for bimetallic strips for precision mirror alignment in space. That was sort of my undergrad. I think the last 2 years of my undergrad, I focused on that work. And I think right about now, I was figuring out that in mechanical engineering, I preferred to focus more on manufacturing and things like that, which for people who probably haven't figured that out, around high school, I wasn't even sure I wanted to do mechanical engineering. So I think one thing you can learn from that is I think you sort of pick a path and slowly you understand what is right for you. And I think that's completely okay. You don't have to immediately know what it is that you want to do. So during undergrad, I also interned at the Indian Space Research Organization, and that was sort of my undergrad thesis work. And I worked on the manufacturing of aluminum waveguides for satellites. And I believe some of the waveguides that I designed and helped build should be flying in space right now. So I think that was pretty cool. I didn't necessarily focus on space research immediately. So as you can see, my background's in mechanical engineering. And I'd done a couple of other internships that had to do with other manufacturing, like manufacturing of valves, tractors, and I even worked on a renewable energy microgrid in California. So here I just have a couple of pictures of, I was also a student athlete, so I was a part of the soccer team, as well as field athletics. So at the top is just a picture of me holding a javelin. And a picture at the bottom left is at me performing, or at the institute where I performed my research. So after undergrad, I decided I wanted to go into the industry. I wanted to get a couple of years of experience before I actually went to grad school. I wasn't 100% sure what I wanted to do for grad school. And so I worked with a company that was working with the Indian Space Research Organization, and I continued to work on the project that was a part of my undergrad thesis. I just brought it to the industry and helped them set up a manufacturing facility that was aerospace grade so that they could actually sell the waveguides back to the Indian Space Research Organization. This kind of was during the COVID years, so I thought I would mention that. And I think I was considered an essential worker only because I was in the aerospace industry, but I did request to work remotely. And I think that really sort of shaped the fact that I wanted to go to grad school sooner rather than later. And it was because of my parents' guidance that I'd actually applied to grad school before I realized that I wanted to go to grad school. And luckily, I got into MIT. And so I did my master's of science at MIT in mechanical engineering once again. But this is when I met my advisor, and you can see my advisor in the picture on the bottom right. He is the guy who's just slightly older than all of us in that picture. But I think I got a little lucky with my advisor. He is an excellent advisor, and I would like to stress that having a good advisor and having a good advisor-advisee relationship is very important in grad school. And they say that you should choose which lab you're working on based off of your potential relationship with your advisor as well as the students that are in the lab. So I was in a lab that was in the Department of Aeronautics and Astronautics. And so this just only reinforced that I did want to continue to stay in the space sector. And I worked on multifunctional aerospace composites. And I worked with carbon nanotubes to make these integrated multifunctional composites. And you can see the picture, the diagram at the top right. Basically what we did was we took carbon nanotubes that have excellent properties, mechanical properties, as well as electrical properties, which allow for the multifunctional capabilities. And we placed them in existing aerospace composites. And the reason we chose that is so that this technology could get easily integrated into existing aerospace technology. And after making the composite, I tested the composite mechanically for strength, because the carbon nanotubes have excellent mechanical properties, and that can be seen when you test the multifunctional composite, and also tested it for different multifunctionalities like structural health monitoring, which basically means the composite can monitor whether it's undergoing a lot of stress, and it can sort of alert you when it might be close to failure. So you prevent a lot of disasters that way. During my time in the master's degree, I went to a lot of conferences. A couple of them were online, but a couple of them were actually in person. And I got to go to Switzerland as well as Belfast. And I got to present my research. And so I think it's really nice to do research and then present it to other people, especially if you do get to go to a conference that's international. Besides that, I mentioned that I was testing my composites for their mechanical strength. So there is a way to test them where you can actually image the composite as it fails. And I got to go to the European Synchrotron Radiation Facility in Grenoble, France, as well as the Super Photon Ring 8 GeV synchrotron in Japan to test my materials out. And so the pictures you see, the picture on the left is in France, testing out my material, and the picture on the right is the one in Japan. And the picture at the bottom is just a picture of a couple of the folks in my lab, and we're just doing a lab social with our advisor, and yeah, just overall having a lot of fun. And I think it's very important to have a lot of fun when you are working on research, because this is a major part of your life, and you want to make sure that you're at least having fun when you're going through it, because sometimes it can be stressful, but having fun is going to pull you through. After that, I began my PhD, and that's what I'm currently doing right now. My PhD is also in mechanical engineering, and I'm continuing to work in the same research lab, but this time I'm working on slightly different work, and that is space radiation protection materials for long duration human spaceflight. So a major problem in long duration human spaceflight at the moment, and this includes like going to Mars and beyond, or even staying on the moon for longer than a short period of time. One of the major issues with that is there's a lot of radiation in space that can make astronauts really sick or give them cancer, etc. So it's really important to shield the astronauts from this radiation. And so I work on the materials that would help shield radiation from these astronauts. And one of the really cool materials that has amazing radiation shielding capabilities is boron nitride nanotubes. So a lot of us may be familiar with what carbon nanotubes are, and those are basically nano-sized tubes made out of carbon. So boron nitride nanotubes are quite similar. They are, once again, nano-sized tubes that are made of boron nitride nanotubes. And they share a lot of excellent properties with carbon nanotubes. And you can see that in the Venn diagram on my slide. But one of the really cool things that boron nitride nanotubes can do that carbon nanotubes can't do is radiation shielding. So my research is in adding a lot of boron nitride nanotubes to either ceramic materials or other materials that are good at radiation shielding, and making these materials for habitats on the moon, or even spacecrafts, as well as space suits. I'm doing this research as a part of the NASA NST GRO Fellowship, and I will probably be working on this for the next 2 or 3 years. Once again, I think it's very important that you're excited about the research that you do, and I am incredibly excited about this as an inspiring astronaut, as an aspiring astronaut, and yeah, I want to make sure that we're able to go to space safely. So that is my motivation behind doing this research. And I got a little lucky that I also work in a materials lab, so I get to put those two things together. A couple of other things that I do, kind of on the side, not really related to research, and I do this at MIT, and I like to call them extra cool projects, can be sort of seen here. So one of the major ones is I was an analog astronaut with Asclepios in Switzerland, and that is a little picture of me in the orange suit. But basically what an analog astronaut is an astronaut that's performing experiments or space duties on Earth. So before you want to send something up to space, or before you go through a long mission in space, sometimes you like to simulate it on Earth in similar conditions. And so as an Asclepios analog astronaut, I got to be in the Swiss Alps as if we were on the moon, and got to sort of simulate a lunar surface stay for 14 days as an analog astronaut. This is just me on an EVA, which is an extravehicular activity. So I'm just outside of the lunar base. And this was pretty cool. It was a year-long training and then a 14-day mission. And I think it really helped me understand what it would, to a certain extent, understand what it might be like to be an astronaut. I am also a MakerWorks mentor. MakerWorks is a student-run machine shop at MIT, and it's run by graduate students as well as some undergraduate students, and we mentor other students who would like to learn how to use a machine shop, or even just use a machine shop for personal projects or research projects. And I think that really shows that MIT's got a community that is willing to help, and I think a lot of grad schools have that. And I think that is very important, because you can't really go through grad school without having your own group of people and helping each other out. I also participate in a couple of NASA student challenges. So that's where NASA is like, hey, what if you figured out this problem? And then a couple of universities try to figure out the problem and demonstrate it to NASA. And I'll go through a couple of them real quick. So on the top right is hydration 3. Basically, NASA went, can you figure out a way to drill into the surface of the moon or the surface of Mars and reach the subsurface ice and extract water from the subsurface ice? And so we had our project called Hydration 3, and we actually won the competition in 2021. And basically, we were able to extract more water than all 10 teams had done for the past 3 years, all put together. So we won by a long run. And in this picture, you can see Professor Jeff Hoffman, who is an astronaut and professor at MIT. He was our mentor on most of these projects. Then at the bottom right is the Homesteading Mars team. Basically, NASA asked us to design a space architecture, like a space mission, wherein we'd be able to sustain human presence on Mars for at least 7 years. And that's our excellent team. We won first place in our theme as well as first place overall. Currently, I'm co-leading a project called Lunar Forge, which is also a NASA challenge. And in this project, NASA asked us to figure out how to extract metal from lunar regolith. So imagine you're on the moon and you want to build a part made out of metal. How would you, and the only thing you have is, I guess, your equipment and lunar regolith. How would you do that? So yeah, that's a project I'm currently working on, and we are using molten regolith electrolysis to extract iron from iron oxide that's present in lunar regolith. So our MRE reactor is in the picture on the top right corner. And a new project that NASA has released is the Lunar Mars Analog, where they've asked us to figure out an analog mission to Mars. So basically, simulate a Mars mission using the moon. And that's a current project that I'm also co-leading. So yeah, fun projects. And I think that brings me to the end of my presentation. And I just wanted to show a couple of pictures of the cool things that you have to keep doing. You have to find time to relax during grad school. And these are just a bunch of pictures of the friends that I've made over the years. And at the bottom right is like a subset of the Mechanical Engineering Graduate Association of Women. And yeah, so my advice is to take part in a lot of clubs that make you feel happy about what you're doing. And there's also a picture of my family at the bottom left. So yeah.
Thank you, Palak.
Thank you so much.
That was really great, your journey from India to USA and, coming from Indian Space Research Organization to NASA and then working in all different kind of projects. You have also been in mechanical engineering, now using material science and using it for aerospace applications. So that's a very good overview for our attendees. We will come to any more questions in the end. It's time now to move to Cadence.